Hey guys, this is Jadav. I'm a third year student from IIT Kharagpur. In this video, we will discuss what is the universal law of gravitation is. So in the year of 1665, Newton was forced to stay at home after his college at Cambridge closed due to the epidemic plague. In that year, he did lot of brilliant theoretical and experimental works in the field of optics and mechanics. At the same time, he was also focused on the motion of moon about the earth. He was studying the motion of moon around the earth. And one fine day, he was sitting under an apple tree. And suddenly an apple fell down. Then he started thinking, why did this apple fall down and why it didn't go up? And this sparked the idea that earth attracts every particle towards its center. Then the Newton had to make some daring assumptions. He declared that the nature of laws are same for earthly as well as the celestial bodies. And he further stated that the force operating between an apple and the earth, and that the force operating between moon and the earth and the sun are all governed by the same laws. And after that, he stated some of the assumptions. He said that the force between any two particles in the universe is inversely proportional to the distance between their centers. If we take any two particles in this universe, you can take this marker and this duster, or you can take earth and moon, or you can take earth and sun, or you can take duster and the earth, or you can take me and the earth. Any two bodies or any two particles. He stated that that force is inversely proportional to the distance between their centers, or inversely proportional to the square of distance between their centers. If r is the distance between the centers of m1 and m2, then this force is inversely proportional to the square of r. This is the first assumption. And the second assumption was the force is directly proportional to the product of their masses. Force is directly proportional to the product of their masses. This was the second assumption. So on combining these two, we get, so M1 M2 is directly proportional. F is directly proportional to the M1 M2 and inversely proportional to the square of distance between their centers. And combining 1 and 2, we will get this. Now on removing this proportional, we add a constant. So force is equal to a constant, let's say Z, into M1 into M2 by R square. So what exactly this universal law of gravitation states is that the universal law of gravitation states the force between any two particles or any two masses in this universe is directly proportional to the product of their masses and inversely proportional to the square of distance between them. That is the universal law of gravitation is. So this is the universal law of gravitation. And this constant G is called as universal gravitational constant. So that constant G is universal gravitational constant. And this is the universal law of gravitation. And the value of G was found is equal to 6.67 into 10 power of minus 11 Newton meter square per kg square. This value of G was found as 6.67 into 10 power of minus 11 Newton meter square per kg square. And this value found after the 71 years of Newton's proposed this law, or stated this formula. So this is the universal law of gravitation. Now we will take two balls and we will measure what is the gravitational force between them. Let's say I have two balls. I have one ball of mass m1 and I have another ball of mass m2 here, and each of 1 kilogram, and the distance between them is 1 meter. Okay, I have mass m1 here which is of 1 kilogram, 1 kg, and I have another ball which is of mass again 1 kilogram, and they were separated at a distance of 1 meter. So this R is 1 meter. Now we have to calculate what is the force acting between m1 and m2. What is the gravitational force that is acting between m1 and m2? So that is F is equal to G into m1 into m2 by R square. So we know G is, let's keep G as G. So m1 is 1, m2 is 1, again R is 1. So this is nothing but G. Right? So force is equal to 6.67 into 10 power of minus 11 newtons. Right? So the units of G are Newton meter square per kg square. We are multiplying with 1 kg, multiplying with one other kg, and by square, 1 meter square, that is meter square. So meter square get cancelled, kg and kg square. So we left with Newton. So force is 6.67 into 10 power of minus 11 newtons. Observe carefully. This force is too small. It's 0.00010 zeros, then 6.67. So the gravitational force between two masses of 1 kg and they are separated at 1 meter is 0.000000067 newtons, which is very small. So that's the reason if I keep this duster and this marker at a distance of 1 meter, let's say 1 feet, they won't be get attracted. This is simply because the gravitational force between them is very small, that they cannot pull each other. Right? If they have to pull each other, then again they have to overcome the frictional forces. Right? If I keep them on table, they have to overcome the frictional forces and they have to overcome the gravitational force between this duster and earth and this marker and earth. This is important. Right? So these gravitational forces value is high when the masses are huge. Right? So that's the reason any earthly particle, on any masses in this on this earth will not get pulled each other with the gravitational force. So this is end.